Okay, geometry. Now, we know how to solve right triangles, because we can use sine, cosine, or tangent, depending on which ones we need to be able to figure out the angles. It's all dependent on the sides we're given with respect to an angle in a right triangle. And that's because of that 90-degree angle. But some of you have asked, what about any triangle? Can we figure out the angle measure or the side lengths of any triangle? And that's what we got today is we want to be solving any triangle. So what does that mean? Just like with right triangles, to solve a triangle means to find the length of every side and the measure of every angle. Now, what usually happens is we have two main ways to do this. We have the law of sines and the law of cosines. Now, these two laws are divvied up on based off of what we're given. If we're given an angle-side combination, we're going to use law of sines. If we're given an angle-side-angle situation, we're going to use the law of sines. If we're given all three sides, we're going to end up using the law of cosines. If we're given side-angle-side, we're using law of cosines. Now notice, those four names up there are the exact same form, or the exact same names for the combinations that proved triangles were congruent. Remember that. If I can prove the triangles are congruent, I can use one of these two to do it. Now, here's the catch. If I'm given that nasty side-side angle, that falls underneath the law of sines. I can still use the law of sines to solve that problem. But this is one you'll have to watch the next video on. It's called the ambiguous case. And it happens when we're given the side-side angle combinations. More about that in the next video. So let's talk about the law of sines. The law of sines says, given a triangle such as x, y, z, with x, y, and z being the measures of the sides opposite the angles, angle x, angle y, and angle z, respectively, then x over the sine of x over the sine of angle x, would have to equal y over the sine of angle y, would have to equal z over the sine of angle z. Every single time those ratios are going. So if I take that side length and I put it over the sine of its opposite angle, that ratio will be the same for every one of these, which is really cool. Because now if we think about it, if side x is the smallest side, angle x has to be the smallest angle. That works out all the way through. Now, I want to point out again, this method will work if we're given two angles in any side. Doesn't matter the side. We can use this method. Why does that work? If I'm giving two angles, I know all three angles automatically. And to be able to use the law of sines, I have to have either both x's, both y's, or both z's to be able to solve it. Now, what you're going to find out in the problems is they don't always use x, y, and z's. They don't always use a, b, and c's. They might use other letters like p, q, and r. So you've got to realize that when I say x over the sine of x, it is a side over the sine of its opposite angle. And as I also pointed out, this can be proven if we're given two sides, as long as we're given the angle that's opposite that side. So let's see, what are we going to get? We're going to get problems like this. Find each measure using the given measures of triangle XYZ. Round angle measures to the nearest degree and side measures to the nearest tenth. So in our case here, we can use our triangle XYZ as a guide to help us out. So I'm going to go in here. Oops. Got that in the wrong spot. I'm going to go in here and I'm going to capture this information. There we go. See if I can get all those to, there we go. I'm going to copy that and put it over on this next page. Okay, so there's my XYZ. And the only reason I'm doing that is so that we can see how it would work. So if I use this triangle and I plug in the numbers I know angle X is 37 degrees. I know angle Y is 68 degrees. So that means I could figure out angle Z if I need it. I know side X is 3, and they want me to figure out what the measure of side Y is. So when I look at that, I'm looking for this side. So according to the law of sines, X over the sine of X would have to equal Y over the sine of angle Y. So I've got 3 over the sine of 37 degrees would have to equal side y over the sine of 68 degrees. Now, just based on that information alone, we should say, hey, side y has to be a bigger number because angle y was a larger angle. So now we just go ahead and we solve this proportion. Now, the quick way to solve proportions like this is we know we would cross multiply and divide. So what I say the quick way is you multiply the two that have numbers in them, and then you divide by the other number that's there. So if I take 3 times the sine of 68, and I divide that by the sine of 37, I'm going to get side y. So 3 sine of 68 divided by the sine of 37 gets me around 4.6219 on and on, but it said to round it to the nearest tenth. So side y is about 4.6. Now, let's look at the next one. Find the measure of angle y if y is 7 and z is 11 and measure of angle z is 37. So now I can kind of move this over. That 37 belongs there. Don't know that number. We don't know angle y, but we do know that side y is 7 and side z is 11. So if you need to draw it out on the triangle, go right ahead. That's up to you. So now I can set up my deal, and I know that y over the sine of angle y has to equal z over the sine of angle z. Now here's a neat thing that I probably should have put in the theorem itself. I could flip these ratios over. I could say that the sine of angle y over side y is equal to the sine of angle z over side z. So it doesn't matter which way I write it. In this case, I think having the sine y at the top is going to be useful to us more so than the other. So now let's go ahead and plug in the numbers that we know. About running out of room there. So I don't know angle y, but I know angle z. So I've got the sine of 37 degrees, and I got the sine of y. Don't know what y is. I know side y is 7 and side z is that. So like the last one, I'm going to go ahead and multiply these two and then divide by the one that's left over. Now that's going to tell me that the sine of angle y is 7 times the sine of 37 divided by 11, which is around 0.38297 on and on and on. Now that's the sine of angle y. I have to find the measure of angle y. Sine of y is not the same as the measure of angle y. So what do? I have to find the measure of angle y by doing the inverse sign, arc sign, remember, of this decimal number. Okay, so I want to use that whole number. So I'm just going to use the calculator and do inverse sign of that whole number. And I do the answer part on there. And it tells me 22.5179. So the measure of angle y is around 22.5 degrees. But it wanted us to the nearest whole degree, so 22.5 degrees would be 23 degrees. Now, could I have done that on my little slip of paper? You betcha. I would have found which number was closer to the 0.3829 or 3830 on my paper. Now, the other part is they want us to be able to solve triangle PQR. So that means we have to be able to, let me get that down a little lower. We'll get back to him in a minute. We have to find the measure of every side and every angle if we solve it. So that means I need to know the measure of angle R. I need to know the measure of angle Q. I need to know the measure of angle P. I need to know what the length of side R is. I need to know the length of side Q. And I need to know the length of side P. I need to find every one of those values. Just like in a right triangle, they got to give me 3 bits of information. Well, they told me angle R is 66 degrees and angle Q is 59 degrees. Well, that means I should be able to figure out what the missing angle is. If I start with 180 and I minus 66 and I minus 59, whatever's left over is my missing angle. 180 minus 66 minus 59 is 55. So my missing angle is a 55-degree angle. Okay, now what about the sides? They tell me that side P is 72. Okay, so here's what I know. I can use the law of sines. R over the sine of angle R would have to equal Q over the sine of angle Q would have to equal P over the sine of angle P. Now, which numbers do I know? I know all of the bottoms. I know R over the sine of 66 will have to equal Q over the sine of 59 will have to equal 72 over the sine of 55. Now, R and Q both have variables in them that I don't know. So what I would want to do here is I would want to, oh good, I can probably group some of these a little bit. Nope. There we go. I can group this set together. I can group this set together. Okay, and then I got this set. Good deal. So what this means is I can set the R equal to the 72, and I can set the Q part equal to the 72. So now in both cases, I just want to solve these proportions the same way we talked about with the other ones. Instead of just doing one, I'm doing a pair. So that means I want to take the 72 times the sine of 66 and then divide by the sine of 55. Or I want to take the sine of 59 times the 72 and then divide by the sine of 55. So if I take 72 times the sine of 66 and I divide that by the sine of 55, I get, 72 sine 66 divided by sine 55, I get 80.29678, on and on and on. So up here it says to the nearest tenth for side measures, so 80.3. Now does that make sense? Well, 66 is bigger than 55, so side R should be bigger than 72, and it is. Good deal. Now let's do Q. So I would take side Q is going to be 72 times the sine of 59 and divide that by the sine of 55. Now when I put this into the calculator, I'm going to talk you through exactly what I do when I do this. 72 times sine 59. I have to close a parenthesis on my calculator, so that way it knows 59 is where I do that. And then I divide it by the sine 55. And again, I close the parenthesis. Every time that my calculator, I put sine down, it gives me an opening parenthesis. So I have to close the parenthesis to make sure it doesn't divide something else out. And when I do that, this gets me a value that's 75.34138, on and on and on and on. Again, to the nearest tenth, 75.3. Now, does that one make sense? Well, Q is the middle angle in size, so side Q has to be the middle length in size, and it is. Great. That one is done. Now, let's look at this one. I've got P, R, and angle P. Remember, I told you we could solve triangles like this as long as I have an angle and a side with the same letter. As long as they have the same letter, I can do it. Because I know it's going to be P over the sine of angle P will equal side R over the sine of angle R will equal side Q over the sine of angle Q. As long as I have a pair, which I do, I have the P's. I get to click that on the wrong deal there. Sorry about that. I have both of these numbers in the P, so I can do this. Like the last one, I need to know what is the measure of angle R, what is the measure of angle Q, what is the measure of angle P, what is the length of side R, what is the length of side Q, what is the length of side P? Now, what I already know is that side P is 32, and angle R is, or side R is 11, and I know angle P is 105. Those I know. So I'm going to plug those in. So I have 32 over the sine of 105 equaling 11 over the sine of angle R. So when I go to solve this one, I could do like I did on the last one and on the other page and go ahead and flip it, but I'm not going to do that. I'm going to say, okay, I got to multiply these two and then divide by 32. So the sine of angle R is 11 sine of 105 degrees divided by 32. So I'm going to go to my calculator. 11 sine 105, close my parenthesis, divide that by 32. It gets me a decimal number of around 0.332037, and it goes on and on and on. Now, to figure out what the actual measure of angle R is, well, what did I do? Put my finger off to the side somewhere. I have to do the inverse sine, the arc sine of this number. And I want to do that as close as possible. Now, again, I could go to our little sheet there, find the closest number to that and use it. Or I can just use on my calculator, inverse sine, and then I say put in that whole number, and it tells me 19.39, on and on and on and on. So to the nearest whole degree, because that's what the direction's called for, that's getting awfully touchy, I would say 19 degrees. Now, I know angle R and I know angle P, so I should be able to find out angle Q. 180 minus 105 minus 19 would give me 55 degrees. 56 degrees. Sorry about that. So angle Q would be 56 degrees. Now, here's what I tell you over and over. When possible, do not use any rounded values. But to figure out side Q, I have to use angle Q, and angle Q was a rounded number. Let that be known. It's going to happen. If possible, use the whole number in the calculator. So I'm going to go ahead and set it back up. I know it's 32 over the sine of 105 equaling side Q over the sine of 56 degrees. So if I'm going to solve that, I multiply these two and divide by the other number that's there. So side Q will equal 32 sine of 56 degrees over the sine of 105. And I would use my calculator for that. So 32 sine 56, close the parenthesis, divided by sine 105, I got to close my parenthesis, and I get 27.465, on and on and on, so 27.5. Using the rounded 56 degrees. If I didn't use the rounded value, and I used the whole angle that I had down here, I found 27.337. So it would say 27.3. In this particular case, if you're in that ballpark for the side length, I'm going to give you credit for it. So that is how you use the law of sines to solve any triangle. As long as you have a pair, so as long as you have both P's or both R's or both Q's, you can do it. Anytime you look for an angle, you have to do this trick right here. Oops, got to bring you down here. You got to do this trick here where you do that inverse sine to find the angle. When you're finding the sides, the answer is the answer. You're ready to go now.